Welcome to our introduction on the project NetMax. Let's introduce the team. First, we have Dax McPartland, myself, Jack Severson, Ryan Taff, and Gavin Kerr. Let's get into it. Right now, network testing at L3 Harris is very complicated. The purpose of NetMax is to provide L3 Harris with a unified application for testing network programs. By using NetMax, L3 Harris engineers will be able to streamline their testing workflows, reduce errors in testing the network, and accelerate project completion without needing extensive knowledge of multiple complex network testing platforms. NetMax manages the integration of key frameworks, taking care of technical complexities. The NetMax software suite will handle API requests from L3 Harris engineers, allowing them to initiate and manage network tests. This level of API integration enables engineers to seamlessly incorporate NetMax into their own projects. Additionally, our application will also include a user-friendly front-end interface, providing engineers with real-time and past analytics related to tests. Lastly, the app will store test configurations for easy repetition and sharing among teams, as well as a scheduling system to avoid conflicts and allow for running tests even while you're out of the office. Welcome to NetMax. Right now, I'm going to walk you through what we were able to accomplish over the last 2 semesters. This is our dashboard. It's just the homepage, just a nice little graphic to mess around with, but our workflow follows this menu bar on the left. So what you'll want to start doing is be able to add a T-Rex chassis. So this is something a network engineer will be able to use to run tests to generate network traffic. So we need to connect to one so that we can manage it. This is the connection page. So you'll be able to name it whatever you want. So this will be our T-Rex chassis demo, because this is for the demo. I know that I have one running at this IP address, so I'll just type that in, and we can add any notes for future developers to be able to use. So this one could be like temporary. So if somebody's opening up NetMax in the future and they're wondering why it doesn't work, they can read the notes and figure stuff out. We can add the chassis. It'll then validate and connect, and it's going to pull a bunch of information about that chassis. So from this page, I'll be able to see all sorts of information that engineers will find very useful for figuring out what kind of tests they can run on this chassis. We have a view configure chassis page. This is where all of them are listed. And again, this is how you can go back to view that T-Rex chassis. Now, the next thing you need to do is generate the type of traffic that you want. That's where profiles come in. So a profile is a collection of data streams that you'll be able to customize to make the type of traffic you want. You can make things look like HTTP traffic, look like video calls, all that kind of stuff through all of our available customizations. So you can customize specific layers of the network as needed or leave them as default, and our program will fill in all the details for you. As a more advanced engineer, they might not want to use this UI, so they can go over to JSON mode and literally fill in everything that they would want to see in their network traffic. After traffic is saved, there is a profile section where we can view all the ones we've already created. Right now, stored in the database, we have a 1 megabit per second test, a 5 megabit per second test, and a 70% test. That'll fill up 70% of the tests like link flow rate. All of these are saved by NetMax, so future engineers can reuse profiles made by other engineers, which will help reduce errors and make sure people are doing consistent testing and being able to share it between all sorts of engineers. Now that we have our profiles, we can create a new test. So a new test, we'll name it. This will be our demo test. We can say how long it's going to run. I'll have it run for 120 seconds. And let's say it's 10 megabits per second is what we want to do, which was the maximum we saw from the ports on this chassis. So the chassis we're going to use is that demo chassis. We can see it there, and it auto-populates what ports are available. Let's choose both ports so that we can be able to run tests on both of them. From port 1, let's run a 1 megabit per second stream. From port 1, we'll run a 70% stream. So that should run about 7 megabits per second. Next. So now that the test is created, we can either schedule the test or run the test. So let's run it immediately so that we don't have to sit here waiting. After we run the test, it will take us automatically to our analytics dashboard, and we can select a test that's currently running. So here we can see that the demo test is running on the T-Rex chassis. This just tells us some basic information, but we can add charts. So here we can see that we have a lot of options for things. So let's look at outgoing bytes, and we can see that port 0 and port 1 are selected, and they're labeled on the bottom. So port 0 is sending about that 1 megabit per second out, while we can see that port 1 is doing that 70% of the test. And there's a lot of information we can look at live. There's no errors right now because this loop back is perfect. And then you can compare all sorts of information live. Once a test is done, we can view tests and we can see that this one is currently running and we can get all sorts of information about it. When a test is done, you'll be able to download all the information as a CSV or as a raw JSON. This will also show scheduled tests, finished tests, and failed tests. Finally, if an engineer doesn't want to use our UI, they want to write some scripts to automatically do things, they can use our Swagger page, which has all of our documented APIs so that they can curl request, here's some examples, from any language or from the terminal to use NetMax. And that is all we have for the demonstration. So now, how does it all work? Well, this is a diagram of our architecture, and I'm going to quickly go over how the project was made. So externally, an L3 Harris engineer can interact with our NetMax Docker container system. Because they don't want this deployed on the internet, we set up a bunch of Docker containers and a Docker Compose that can be deployed in labs or at different locations very easily, and that's what this box represents. L3's engineers will first interact through the Nginx proxy, so if they're going to the front end, it'll get routed up to the front end container. If they're using our API, it'll go straight to the back end and they can manage it from there. Our front end is a React project that uses shadcn, Tailwind CSS to build really nice looking TypeScript and JavaScript. It communicates with our backend using our REST API and SignalR for live analytics and other live information. The backend is a C# project built on .NET Core using SignalR and REST for command and control. Finally, the backend connects to a Postgres database that we use for storing tests, storing profiles, and everything else that the project needs to remember over long periods of time is stored in the database. Finally, the backend communicates with network traffic generators like T-Rex we showed in the demo. And that is the overall architecture of NetMax. In summary, over the last 2 semesters, our team was able to complete 180 issues with 480 commits. We worked with L3 Harris engineers to get feedback on our project and help refine the features that they would need and use. And we created a CI/CD pipeline that helped do automated testings throughout the entire process. Thank you for listening to our video, and special thanks to L3 Harris for working with us and sponsoring our project.